Hello. I am back. I am here.
Discovery, go at throttle up.
Yeah, Maz, that's right. 92-month resub. DIY Auto. WD-40 with the 23-month. Welcome back. Welcome back, Mr. Streamer. Thank you, everybody. I hear the voice of a space nerd.
Discovery, go at throttle up.
Hey, Vulcan. ITAR. I got a chuckle out of that. I got a chuckle out of it. Not gonna lie.
Discovery,
Not gonna
go
lie.
at throttle up.
Laserman, 19-month resub and plus with a 72-month or 6 years. That's awesome, man. Sweet. Thank you. Finally got around to watching Talladega Nights.
Discovery, go at throttle up.
All I have to say is Hakuna Matata. What? That's...
Discovery, go at throttle up.
Okay. Marco, 2-month resub. Panic Backflips, 8-month resub. There you go. There you go. This is a ZZR600.
Go at
Or
throttle
a
up.
ZZR600. I don't have the knowledge to do so. Plus, it's a fully faired and highly tuned bike.
Discovery,
Yeah, I don't know
go
what
at
that
throttle
means,
up.
but alright. Starship review. Yeah, I know, right? We all know that that's what's going to happen. So how about that Starship launch? It's one of the coolest launches you've ever been to. Laserman, thank you for the 2 subs. Blue Flare,
Discovery, go
also
at
this
throttle up.
38-month resub. Hey, SpongeBob's back. Bubble Bass. I'll take a triple patty
Discovery, go at
deluxe.
throttle up.
Burn it, float it on a raft, and let it swim. Still no pickles. It's a great episode, Elwood. Chris, 32 months. How's the Bronco treating you, dude?
Discovery, go
Everything
at
good?
throttle up.
High Space is live. Screw Starship. How about that Slick 6 news? I really hope it eventually comes for Starship, man. And there's my car, and there's my ride. Early start, be like, bleh.
Discovery, go at throttle up.
Dynast Apoluna. What's going on? This isn't original at this point, but I feel like I started watching in high school just potentially finish
Discovery,
potentially
go at
finish a
throttle up.
degree in ME. Mechanical engineering is sweet. Building things is literally the most base thing in the world. Yeah, I never thought I'd say that on stream, but it's true. So, yeah. Graph 41 months. Buttons! What's going on? It's very nice. Need to get the tints on it because
Discovery,
Florida's
go
hot.
at throttle up.
Indeed. Seeing that big steel monster go up in the sky was a euphoric experience. How was it? I was kind of like debating doing an off, like, a stream. Like, okay, so first of all, I can say it now. We went to Detroit. That's where I was over the weekend, Friday, Saturday, Sunday, Monday. Bree and I went to Detroit and we had a wedding shower with Bree's side of the family for, yeah, so that was cool. Got to meet a lot of, well, not meet, I knew most of them already, but got to hang out with a bunch of future in-laws, which is sweet. So about that crater and starbase, how long do you think it will take? I'll get to that in a moment. Completely off topic. Razor Black Shark V2s, Jazzo. Spearcraft 69-month resub. Doom, what's going on? I really want to see the second launch. Cool, isn't it? Yeah, Shayna had a Discord AMA that we did miss. I literally fell asleep. I tried to come back. Hakuto R is landing very soon. And a Starlink launch got postponed until tomorrow. Yeah, okay, cool. So, guys, wedding shower. Didn't think anything... Not that I didn't think anything cool was going to come of it. We put a bunch of things out. Like, when you have a wedding, you put a bunch of things out that you need for your house. Like, you usually don't get, like, specialized gifts. However, with that being said, we got pots and pans. We got a bunch of good stuff. We got a turkey cooker pot. It's great. But just in case anybody was wondering about how well Bree's family understands me, this was in the plethora of wedding shower gifts. I like my t-shirt. Thank you. You like my t-shirt? Yeah. Any C4? No. No, this was in there. And at first I thought, that's a really weird kitchen appliance. I don't understand what this is. But then, yeah, Maz, you know. But then, oh look, see, I can see you guys. See? They're towing mirrors for the F-250. Bree's uncle, one of Bree's uncles got me towing mirrors for the F-250, and I don't, I'm not upset. I'm not upset. That's awesome. Yep. I got car parts for my wedding shower gifts. Did he give you something to tow to need them? No. It turns out, do you have a super snake? Wait, what do you mean, Breezy? So, did I shed a tear? I didn't know what it was. But it turns out that Bree's family, who's from Detroit, also likes cars. A lot. Can't imagine why. Your favorite uncle territory? Yes. Yeah. It's gonna be in the summer, Driados. But yeah, so I got towing mirrors for the F-250. Are you covering the landing on the moon today? Yes, that will be encompassed into our space and rocket review. So what are we towing? Well, I need I need a trailer. A trailer that can haul cars, obviously. Either that or we're just inadvertently turning the F-250 into a camper special. You need to get a toter home. Tessa, it has the mounts for a fifth wheel. No joke. It has the mounts for a fifth wheel. The holes are already in the bed. They're streaming now, just so you know. Yeah, I know iSpace is live. Yep. A trailer to tow cars to, say, Florida? Or, I mean, maybe we could tow, like, a studio. Or an Airstream or something. Car schmars, haul machine tools. Well, a car trailer, would also be able to do that. Also, dude, I took my parents, Bree's parents and my parents, we went to the Henry Ford in Dearborn, which is, it's a museum to American industry, right? Oh, I forgot how much I like that museum. I forgot how much I like it. It's such a good museum. Sitting next to a single expansion steam turbine power plant, or not steam turbine, single expansion steam piston power plant with a flywheel that's 20 feet in diameter is very nice. Towing a thingy to, yeah, I don't know, maybe. Dude, I went to the track day over the weekend, and now all I can think about is building a race car. Yep, you got the car bug, Shaw. Yeah, that happens. Yeah, it's like the space bug. But see, you can do all the cool things that you see in space, except for like doing the flying part into space with a car. It's the same kind of mechanical itch, so to speak. That's why I do it. The Henry Ford Museum is awesome. Greenfield Village is the museum that our favorites for taking the kids. Yeah, Toast, exactly. We didn't get to go into Greenfield. The weather wasn't good. They were like, don't go to Greenfield today. Then we were like, all right, cool. So, yeah, seeing all the industrial equipment, dude, that made EJ very happy. And it's funny because me and my dad, I'm slowly becoming my dad, and we're the same person. Like, I was like, ooh, industrial equipment. And my dad's like, ooh, industrial equipment. And then Brimo's dad is like, ooh, industrial equipment. Let's go check that out. I'm like, yep, this is good. This is good. This is a good thing. I like this. Ooh, industrial equipment. Ooh, industrial. Ooh, piece of candy. Ooh, piece of candy. How does your fiance feel about receiving a mirror for a wedding gift? That was a small one, Smitty. She thought it was funny, actually, because I didn't know what it was. I was not expecting car parts, and yeah, I got car parts. But we got a lot of other good stuff too. Let's load up that iSpace stream here. And we got a lunar landing for our Kudo R, guys. I think that's where we should start. Because this is happening right now. And then Starship. And then maybe some cities after that. How many new toasters and kettles did you get? Oh, yeah, a lot of that stuff, yeah. I thought iSpace wasn't streaming. Well, you thought wrong.
Orbit insertion. So the orbit insertion is...
I was kidding. My father-in-law gave me bullets and parts for your hunting rifles.
To the orbit from
yeah, Smitty. No, it's pretty good, man. That's pretty good. I'm not complaining. Yeah. Oh, you missed it, EJ. I want to race in GTA on Saturday. Okay.
and then do less than a minute of.
How did you manage? How did you happen to find a family that is just you? That is just your family from Detroit. Imagine the. Yeah, Bree and I have talked about that. Super. Our families really don't have any problems. We all get along. Yeah, I don't know. I don't know, and that's. I'm just gonna chalk that up to those one of those inconsequential, universal probability things. That's like highly unlikely for happening. Yeah, and just kind of roll with it. I'm not gonna ask questions. Don't stare a gift horse in the mouth. You know what I'm saying? Like, I think it really kind of came from putting myself out there. That's the biggest one. Put myself out there on the stream. You're all aliens. That's your answer. You get what you deserve. Yeah. Yeah. Maybe Vulcan. Yeah, let's watch Hakuto and then we'll go from there. Do you have an infinite improbability drive? Yeah, something like that. Yeah. Hey, Paul, what's going on? Let me see your teeth. Oh, yeah, you got healthy gums.
It means that we're going to reduce the speed for the landing. So as you can see now, the velocity now, we are changing the velocity from 6,000 kilometer per hour to 100 kilometer hour. So basically, we are going from the spacecraft speed to like a Shinkansen speed now to land on the moon. So then altitude also changing from 25 kilo to 3 kilo in this phase.
So the lander gets closer and closer to the moon and keeps slowing down. What happens next?
Yes, the next phase is phase...
So what we're watching here is the Hakuto R lunar lander. Hakuto R was delivered by Falcon 9 on a ballistic lunar transfer trajectory, basically launching this thing out far enough, like way past the moon, to where by the time it reached apogee, the moon was kind of near it, and pulled it in. And it circularized basically for little to no delta V. Ballistic lunar transfer is the one of the lowest energy ways to get to the moon, but because it's a lower energy transfer, it takes a really long time. Hakuto R launched a good while ago. In fact, let me get that up. Nope. Hakuto R did launch on a Falcon 9. We did watch it. I didn't want to miss a lunar. Yeah, it launched on December 11th, 2022, and has been transiting out to the moon for the past 4 months. How big is it? It's a small lander. It launched on Falcon. I'm trying to see if we can get. I'm trying to see if I can just bring up all the information on it, dudes. Give me 1 second. I'm trying to get back into the shake of things. The mission elapsed time on the iSpace website is 135 days, 7 hours, 27 minutes, 46 seconds. They should have used time warp, dude. But if you check this out here, that's their approximate position. That's cool. Here, let me do a side-by-side. If you look right here, that is the ballistic lunar transfer. Falcon 9 launched this basically on it's something kind of akin to a super synchronous insertion. They launched it with its apogee way out here. And basically, when it hit apogee out here, the moon flew by, and it used little lunar gravitational perturbations to pull it in. And then by the time it got pulled in, it basically did a small circ burn and captured the moon, which is what you see in this over here, which is actually really cool. They should be landing more or less soon. Here, let me see. The idea is that you basically they used the second stage to do the transfer orbit. And because with the ballistic lunar transfer, your orbital speed around Earth is very close to the moon's orbital speed, it's a very, very small, inconsequential delta V burn to get it to circularize, which is actually really, really cool. So the incoming velocity approach is minimized. Direct homing like we do in KSP requires a lot more fuel on the vehicle. Bingo. Exactly. Inconsequential amounts of delta V to circularize. You could do a ballistic lunar transfer. You could do BLT. You can do BLT in KSP. In fact, they did BLT in Human Space Program. They did BLT in HSP. True story. Yeah, about 30 minutes out, give or take. Yeah, okay, cool. All right. It's not every day we get to see a lunar landing here, but I covered the launch, and now we're going to get the landing here. This lander is very tiny for what it's worth, guys. Yeah, somebody did ask that. Sorry. Just getting back into the groove here. It is not a big lander. I don't know. Maybe it's smaller. I'd say about the size of a smart car if I had to guess. It's not very big. Like a person couldn't ride down on this. But either way, anytime we see a lunar landing is pretty cool. It's not very big, guys. It's not a big lander. Think like Tesla Roadster inside of the Falcon Heavy fairing, like that big. It's not very big. Here, let me tee them up and see what's going on here. Doom, now at 3 months, thanks for the great work. My pleasure, man. Thank you for watching. Merci beaucoup.
Throughout this landing process.
All right, I need to go make coffee. I'll be right back. 1 second.
All the experience throughout this mission.
Getting back into the groove.
For the more sustainable lunar activity that you are going to do, and to expand this lunar exploration activity to a more global one. So Godspeed iSpace, Godspeed Hack2R. Thank you.
Thank you very much.
Thank you.
Thank you very much, Professor Tsuda, and we wish you all the best with your future endeavors. Please enjoy the show. Next, I am happy to welcome Airbus Ventures Manager, Partner Thomas Delawin here on stage with us. Airbus Ventures has been one of our first international shareholders, and they possess a strong insight into the global space industry.
Thank you. And first, congratulations, Akamada-san, the entire iSpace team, on this historic moment.
Thank you very much.
And thank you for bringing all of us closer to the moon and to the moon, right? So Airbus Ventures, Louis, my friend, and the entire team, we cannot be more proud today to be here joining in this extraordinary milestone for the space economy. Maybe a word about the moon. We at Airbus Ventures and you at iSpace value the moon as a vital system component in harnessing natural resources in order to deliver clean energy, rare metal, but also biosphere-friendly manufactured product to Earth. But the moon's development is also critical for alleviating the compounding stresses that we've seen on Earth, climate and Earth biodiversity. This is also a tremendous opportunity, a business and economic opportunity that now we see iSpace uniquely positioned to pioneer. So this world is full of planetary system challenges. iSpace now, with the talent, the global mindset, but also this sustained vision and the thorough execution and the global team building along these years of development, is a key actor to address those planetary challenges. So our message to the team is to keep going. The moon is a way. And please, again, congratulations for this historic moment. Thank you. Thank you, Akamada-san. Thank you.
Thank you very much.
Thank you, Mr. Delawin, and we are very excited for what the future may bring for private space. Now, I am very excited to welcome another iSpace crew member here at our venue. Scott Moon, our lead assembly, testing, and integration manager, who helped not only build the Series 1 lander for Mission 1, but who is already working on our Mission 2 lander. Hello, Scott, and please take a seat and tell us a bit more about how the Mission 1 lander came into existence.
Sure, Kevin. So I had the good fortune to join iSpace in November 2020, and in April of 2021, the iSpace team was deployed to Germany to begin building the M1 lander. We spent the next year in Germany building the lander in those facilities, and after 1 year, we moved to Munich to start our test campaign on that lunar lander. When we were in Munich, we ran tests that allowed us to simulate the environment that we would see in deep space. We ran tests to simulate the environment we would see during the SpaceX Falcon 9 launch.
Over the weekend, dude.
And we ran tests of all of the systems that we needed to use while we were in orbit, while we were descending, and while we were in operation on the moon. Once we finished all those tests, we packed up our operations in Germany, and we flew on a specialized cargo transport over the Atlantic to arrive at Kennedy Space Center in Cape Canaveral. The AIT team personally escorted the lander over, and once we landed in Florida, we spent 2 months with our launch preparations, which included fueling the lander and doing a final systems checkout. After those 2 months, we said goodbye to our lunar lander, we put it inside the fairing, and it was integrated into the launch vehicle to be launched in December of 2022. That's basically the M1 story in a nutshell.
Thank you, Scott.
You're welcome.
And again, thank you for your hard work.
Wait a minute. This guy's name is Scott Moon, and he works on a lunar lander. Okay. All right.
Payload customers on M1 from iSpace Chief Revenue Officer Atsushi Saiki.
¿Cómo estás, amigo? He's Scott Speed's cousin. Ah, yes, yes.
Saiki-san, tell us, who is going to the moon with us?
Okay, thank you, Kevin.
Atsushi Saiki.
On Mission 1, we are carrying a number of government and commercial payloads.
Makes sense to me.
Our payload service does not only consist of bringing something to the moon, but also iSpace closely communicate and coordinate with its customers to integrate each payload into the lander and its system. Secondly, the payloads are tested before the launch to verify their ability to survive the long journey to the moon. And iSpace further offer power delivery and communication service to payloads that require it during transit to the moon, as well as after successful landing. Throughout the mission, our Series 1 lander also offers protection from the harsh environment of space by providing thermal control and other services. Our payloads on Mission 1 vary in size, mass, and objectives. Some of them are mobile, and we plan to deploy them from our lander after touchdown, such as the MBRC Rashid rover and the JAXA transformable lunar robot. After deployment, these rovers will begin their mission objectives on the lunar surface while sending and receiving data and commands via our Mission Control Center in Tokyo. Other payloads will stay integrated into the lander. We carry experimental solid-state battery for Nitera, which perform verification tests of this new battery technology under extreme environment in space and the lunar surface. Further, we carry several payloads within the Canadian LEAP program, an AI-powered...
Oh, dude, don't worry about it. I don't know that much about Hakuto, so when I don't know something, I shut up. Like, when I don't know something about a payload, I kind of just let them talk. So, also, if it's sponsored by Suzuki and it's really, really tiny, that means it packs a huge punch. So, yeah, because Suzuki. Hey, Suzuki Samurais are cool, all right? I will die on this hill.
Value to our customers, not only in terms of space and lunar exploration, but also in the development of new technologies that could benefit human society on Earth in the future. Thank you, Kevin.
Thank you, Saiki-san. And we are all super excited to bring more and more companies to the moon.
Yes.
Now, for a bit of background on how our lander and its payloads are deployed and operated after landing, let's hear it from our MCC crew again.
Thank you.
So, how much do you want to bet that this guy hasn't slept in a couple of days? Not that guy. The guy sitting on the left of the two. You're on. You're on. You're on camera. Okay.
As soon as our spacecraft detects contact with the lunar surface, it will go to TDM, which is touchdown mode. It will cut off the engines and make sure that we're stable on the lunar surface. After that, we'll perform many checkouts to make sure every system and our customers are still working as expected.
It's gone.
One of the first things that we will do is deploy our high-gain antenna when we're on the surface. So our high-gain antenna will allow us to download all of the data and pictures and photos that we've taken throughout our mission. The lunar environment is completely different than the environment we've been facing up until this point. Most people probably think the moon is this cold, desolate place, but it can get very hot in the sunlight, up to 120 degrees C. So the first thing we'd do again is a full checkout of our system.
And once we have our high-gain antenna, which allows us to send much more data back to Earth than we could in cruise, then we're ready to deploy our customer rovers.
They were turned
the bigger
off
one is the MBRSC rover.
The Starship coverage, guys.
So
I have
it
them
has
back
been
on.
flying
Thank
up
you.
here. Once it's time to deploy, the arm folds down with the rover on it, and then we release the rover, and it can drive off to go do some great science.
I mean, whoa.
Thank you to Katie and Haroon, and all the best during those first moments of surface operations. Now, we are happy to have a quick message from a very special guest. Yamazaki Naoko-san, a former JAXA astronaut who flew on the space shuttle to the International Space Station, will very soon be connecting remotely with us. Yamazaki-san, hello, can you hear us?
Hello, Kevin. Yes, I can hear you very well, and congratulations for your achievements so far.
That's cool.
Yes, I am so thrilled and honored to be with you for the upcoming historic moment, first ever private lunar landing. First of all, I'm so proud of the entire iSpace team, including families, for the remarkable achievement to get this point. As an astronaut, I cannot overstate the importance of this mission, which expands our frontier for all humankind. My dream is to open a school on the moon someday so that various students from various countries and regions can learn together on the moon, watching the Earth from a distance. The moon has a huge potentials in many ways, so it is important M1 and following missions will secure high-frequent transportation to the moon, which will secure human presence on the moon and allows us to have a big dream.
Dude, he was sleeping.
Also, as a member of the temporary member of National Space Policy Committee of Japan, M1 means a lot to governments too. iSpace is the first company to be covered by Space Resources Act in Japan and awarded a contract with NASA for lunar resources. And M1 contains UAE's lunar rover and Canadian, Japanese payloads and so on. When I visited iSpace Mission Control Center in Tokyo a couple of months ago, I had the privilege to write a message on the wall, and I wrote, "Fly our dreams to the moon." So thank you very much for flying our dreams to the moon.
Never give up.
So proud of your never give up spirits. All the best and Godspeed.
Arigato gozaimasu. Never give up. You seen that meme?
Thank you so much, Yamazaki-san, and it's always a great pleasure to have you with us. Now, let us have another quick look at our status screen. Hitachi-san, looking at the status screen, I hope we have it now here soon. Yes, what phase would you put us on now, more or less?
Yes, I believe the lander is still in the phase 2. That's a cruise phase. So, as I said, this phase takes about 40 to 50 minutes. So I hope that in the about in the 10 minutes or so, I hope that the break and burn starts. But at the moment, I believe that the lander still is in the cruise phase, flying with a speed of 6,000 kilometers per hour. But altitude now, you can see the altitude. Altitude is now getting now closer to 25 kilo from the surface.
Thank you, Hitachi-san. And Hakamada-san, we soon hope to regain contact with our lander. Are you looking forward to meeting him again?
Yes, I really looking forward to reconnect our lander and then start the next phase of the landing.
Thank you. And while we wait, let's see where exactly our lander is planning to set down on the moon.
I'm looking at the
We are
velocity.
collaborating with a group of international experts to have finding suitable landing sites on the moon. This can allow the missions to have 12 days of sunlight on the lunar surface. Let's start with where are these 4 candidate landing sites?
Well, we're having 4 landing sites. One prime landing site, which is the most exciting one we find, which is at Atlas Crater. And we have 3 backup landing sites. One is not too far from the prime landing site, which is Lacus Somniorum. One then in the western hemisphere, where we have Oceanus Procellarum and Sinus Iridum. All of our landing sites are in the northern hemisphere and are very exciting for their scientific potential and are well suitable to act as
you can see all
backup
the
landing site in
all
case
the other
the
landing
landing
sites.
does not work off any of the others.
Those up there, the Soviet
We
lunar
selected
missions?
our site using both scientific and technical criteria. So, for instance, we
And then
want
the
to
Apollo
go
sites
to a
too.
place relatively flat, devoid of boulders, but we also want to maximize the science output with having some geological diversity. And in order to proceed, we collected data from space mission currently orbiting the moon that we processed. We tried to translate our criteria into calculation steps, and then we came up with a list of possible sites that we scored and we
Change up
ranked.
the title, fellas.
I think from the beginning, the landing site selection working group started with having safety in mind, the safety of landing, and also safety of Rashid rover traversing the moon. Rashid rover is designed to overcome obstacles of up to 10 centimeters of height and also to drive over slopes of maximum 20 degrees. When we reach there, definitely we have a lot of ideas to do a lot of science experiments. We are going to study the regolith on the landing site, and also we are going to study the thermal characteristics, and also we have nice and exciting ideas on experimenting with different materials interacting with the regolith on the landing site.
So my role was to further optimize our landing site selection, make sure that there was alignment with both our lander team here in iSpace as well as our other customer payloads, as well as to establish our own science objectives to help with the continuous improvement of iSpace lander and rover exploration missions into the future. Each of the 4 selected landing sites are incredibly unique and will offer fantastic scientific value, and they're just really exciting opportunities.
To land on any of the given landing sites, we have to make sure the spacecraft is passing over it. But then as the moon rotates over in its own axis, we only have one given opportunity every lunar month, right? So every 28 days. So in order to minimize the time that passes between any of the prime and any of the landing opportunities, in case there's any deviation from the nominal, then we selected these 3 landing sites that will be accessible within just a few days.
And a big thank you to our colleagues at MBRSC, CRPG, iSpace Europe, and everyone else who contributed to this very critical part of Mission 1. Now, while we wait for the lander to reappear from the far side of the moon and reconnect with our ground station, let us hear about what we can look forward to over the next couple of years. I welcome iSpace Director and Chief Finance Officer Junpei Nozaki.
Don't clap the microphone, man.
Okay, thank you, Kevin. So while I wait for Mission 1 landing, let's talk about the future. So we have Mission 2 next year and Mission 3 in 2025. And let me explain. Mission 2 will use a Series 1 lander, same as right now in the space. But we'll also bring a micro rover, which currently our Luxembourg team is developing. And also for Mission 3, right now, our next generation lander, Series 2 lander, is manufactured in the US, Colorado, Denver. And this will bring 2 satellites to the lunar orbit. And also, they will land on the far side, Uragawa, of the moon. So this is a very fantastic mission going forward in 2025. And also, Mission 3, we are going to bring NASA payload under a program called CLIPS, Commercial Lunar Payload Service. So we will contribute to NASA Artemis program too. So next page. I like to stress most important thing about a sustainable business model. So we are not a company doing just one single mission, but rather we are doing 3 missions at the same time altogether. This is very important because while we are doing Mission 1, we can feedback what we learned from our Mission 1 and the data what we acquired from Mission 1 to Mission 2 and Mission 3 rapidly. And this is really important to improve our maturity of technology and also maturity of a business model. And also for startup companies, the financing is really important. But we are very proud and we are very fortunate that we could raise more than $300 million of money so far to support not only one single mission, but all 3 missions together. So this is an important point to create a sustainable business as iSpace. So we are now closer to the landing. And I strongly believe we can have a good achievement. But however, if whatever the outcome is, our company will go and continue. And also, I promise never quit the Lunar Quest. So thank you very much, Kevin.
Thank you, Nozaki-san.
So that right there is parallel. That's parallel development. That's used in the aerospace industry all the time. All the time. I can give you a pretty recent case in point. Booster 7 is not like Booster 9 for Starship. Parallel development. And I'm not going to sit here and say that they didn't learn some stuff from the Starship flight the other day. And I guarantee you those lessons will be applied to newer Starship boosters in the future. But anyway, we can talk about Starship later. Let's go back to the lunar landing.
Thing that I described earlier, we gained a lot of valuable information about how the lander responds and how it fits together. And our design teams have already incorporated all that information into the design of the M2 lander, making some small improvements to improve the performance. Yep. Also, the last 100 days in spaceflight have given us very valuable information about how we perform in space. And this information has also already been incorporated into our updated design. So we spent the last 4 months with our teams building a development model of the M2 lander, and the testing on this has been completed 2 weeks ago. This information tells us how the new design will be performing. We're also incorporating this information into our new design. And I'm really happy to announce that as of last week, we started building M2 flight model lander. The first pieces have already been assembled, and we are on our way to the M2 launch.
Thank you, Scott.
You're welcome.
And it's really amazing that even while Mission 1 is still ongoing, we are already working on our next mission. So good luck to you and your team. So I have a good life update for all of you. We received word that the lander has reappeared from the backside of the moon. And it's on its final orbit, only minutes away from the planned landing.
Oh, it's slowing down. Yeah.
So,
okay.
Hakamada-san.
So, in order to slow down correctly, low lunar orbit speed here is about 1,600 meters a second, or about 6,000 kilometers an hour. You can clearly see that it is descending. It has started the entry, or not entry. It's not really entry. There's no atmosphere. There is, but I digress. You wouldn't really call it entry. So we're down to about 4,000 here. So we're a little over 1,000 meters a second here. 25 kilometers up. Touchdown 8 minutes 30 seconds. Radar altimeter is on. In a second here, it should pitch up. I mean, guys, like, I'm not going to lie. This is one of the things that Kerbal gets really right. If you play Kerbal and you landed on the moon in Kerbal, you know exactly what's going on here. It's just instead of coming down from a 500 meters a second orbit, which is low Mun orbit in KSP, this is 1600. The lunar gravity will pull you in a lot quicker in real life than it will in KSP. And even in KSP, it is difficult if you don't know what you're doing, right? I mean, my first lunar landers a decade ago, I'd failed so many times. But
Discovery, go at throttle up.
Yeah, they've started their initial powered descent burn, so it's PDI 1202, 1201, indeed. Oh snap, with the Apollo reference here. Hey Maverick, thanks for the resub. Whiskey, thanks for the resub, dudes. Appreciate it here. Yeah, I'm gonna try not to talk over them too much. There are many Vulcan-designed landers littering the surface of the Mun. Yeah, I mean, Vulcan. My first lander was space shuttle shaped. I kid you not. Yeah, I used the Mark III fuselages and 3 downward-facing LVT-45s to make a shuttle lander because I wanted to land a shuttle on the moon. That was like my first thing, and I couldn't get it right because the 2 engines in the back were too far back, and my center of thrust wasn't lined up with center of mass, and it flipped over a bunch of times. But I finally got it. Dude.
Can you explain it a bit more?
Oh yes, yeah. So this is the picture of the Earth lies on the moon. But most interestingly, as you can see, if you can take a very closer look at the Earth, so we see actually the shadow of the moon on the Earth. So you see that black spot there, the close to the Australia. So this is actually the shadow of the moon. So
that's the northern parts
took
of
this
Australia,
picture during the solar eclipse. So it's really interesting to see this kind of the phenomena, not from the Earth, but from the lunar orbit. So
Japan.
This is very interesting and very exciting picture.
Thank you, Hitachi-san. And I believe we also have a video that I would like to share with you.
Wow.
Hakamada-san, doesn't this look amazing?
Oh, that's
well,
cool.
This is real video.
Oh my
Yes.
Not
goodness.
CG.
No.
It's amazing.
It's really hard to believe, but it looks amazing.
Hold on.
So Hitachi-san, we see something in the lower part of the video. What is this?
Yes, I think this is a part of our lander. So this is a part that we call...
Guys, at the very last part of that footage, there's a roll rate that gets induced on the vehicle. Watch. The perspective from the ground starts to move, and the camera cuts. Just something for thought. I'm not sure if that's anything.
It's really amazing to see.
Is this KSP too? No, this is HSP, Human Space Program.
A part of the moon. So because there's no
Watch.
atmosphere on the moon, so we can clearly see the lunar surface, and this is really amazing video. I'm really.
It's not
amazed.
in the right axis, Vulcan, for that. Look,
Thank
see,
you.
right there. It starts to.
And I believe we have one more image. Yet again, a
Bruh.
video.
Polar orbit.
Hakamada-san.
They're in
Well,
polar.
another amazing
Dude.
video. I cannot tell any word. Beautiful.
It really
Dude.
transcends words.
Dude.
And it is just amazing.
Dude.
So now I would like to ask
Dude.
Hakamada-san and Hitachi-san to join our crew on your seats. And for the last few minutes, we are almost 5 minutes before planned landing. I would like to ask you to
I don't know what
continue
to say.
viewing the event, and let's all root for our lander while we wait for the planned landing.
Thank you.
Hypo-sama. Ohayo gozaimasu.
And now, looking at the status screen, the lander is still moving over 2,000 kilometers per hour.
600 meters a second. No, well.
Please let me point out here that we
it's around
might
there.
lose communication with our lander during descent. This is to be expected, and we will reconnect as quickly as possible. Also, if you see any sudden changes in the simulation, this might also be caused by our system of how we simulate it. Even if the lander appears to be on the surface or anywhere else, please wait for our final confirmation from our MCC. As soon as we receive final word, we will share it with you. And you
guys see that
our
monitor?
MCC crew.
Hold on. The monitor. That monitor
getting
was
ready
nuts. What are,
for the moment.
Somebody call Linus. We need those monitors ASAP. When was this launch from Earth?
Anxiously awaiting.
December 2022.
Getting the stations ready.
So this lander used what's called a really low energy transfer, meaning that it was launched on a Falcon 9, and Falcon 9 pushed this thing way past lunar orbit, and they basically pushed it way past lunar orbit. So when the moon kind of came around from its orbit, right? And the satellite was way up at the top of its orbit when you're going the slowest, the moon's gravity pulled it in. It's called a ballistic lunar transfer. And the idea is that you don't, because you're going, it has such a low relative speed when the moon starts to pull it in, that when you get to the moon and you try to circularize around the moon, because you got to hit the brakes, right? There's no way to hit the brakes except take the accelerator and point it in the opposite direction that you're going, right? You only have one rocket engine pointed in one direction. You got to flip it backwards and basically use the rocket as a brake, right? Like what it's doing right now. It basically captured with a very, very low amount of fuel because it used the moon's gravity to pull it in. It's really cool. Ballistic lunar transfers are crazy, but they take a really long time. That's a stark contrast with like Apollo. Apollo was a very high energy transfer, and it only took 3 days. But they needed a ton of fuel to basically step on the brakes when they got to the moon, or else they would have just flown right past it.
L minus 2 minutes.
Okay, here we go. Can you do that
Close
in KSP?
to 500 kilometers per hour.
Yeah.
Under 6 kilometers above surface.
Okay. 5 kilometers off the deck.
We are only moments away from the planned touchdown on the lunar surface.
No one.
Everyone who worked on this mission is anxiously anticipating how it will turn out. Please note again, communication with our lander may be interrupted during descent, and it might therefore take a little bit of time for our ground crew to confirm the status of our lander. We will share the latest situation with you as soon as possible.
It's telemetry.
Even if you see the lunar lander landed on the surface, we will update you as soon as possible. Now only 200 kilometers per hour, under 3
Come on, baby.
Kilometers above the surface. Only 1 minute to go.
The radar altimeter is converging on the landing point. That's what that plus sign is, I think.
190, 180 kilometers per hour. Under 2 kilometers.
1 mile off the
deck. The lunar lander keeps braking. Now in vertical orientation.
This is looking good, dudes.
Only 1 kilometer above the surface remaining. We're getting closer and closer. About 120 kilometers per hour,
miles an hour.
700 meters.
We're about a quarter mile off the deck. 60 miles an hour.
We will soon have reached the planned landing time, at which point
slow down.
I might ask you to wait for a few moments for us to confirm the status. 60 kilometers per hour. 20 meters, final approach.
Come on, baby.
10 meters.
This is looking
and
good.
Our simulation might have lost its connection with the MCC. No reason for concern yet. We are still seeing the animation going. 3 kilometers per hour. Only meters above the surface now.
They got this. They got this.
And now we are at the moment of planned landing time. Again, everyone, please give us a few moments to confirm. We hope to maybe receive a message from our MCC soon.
The lander telemetry looks
good. If that
is
not the case, then we will need a few moments to continue investigations, and we'll update you as soon as we have new information.
If this is real telemetry, that looked right. It looked right to me.
Our MCC crew standing by, waiting to confirm.
Come on, guys.
Everyone is laser focused right now.
This guy's like, hold me. The animation was not telemetry driven, but the numbers
really
looked
feel the
right.
tension.
Come on. Come on. Yeah, no one's doing this. So that means they haven't gotten confirmation yet.
Please allow us
Gooey,
a little
fine.
bit more time to confirm the status of our lander.
Lunar gravity is only 1/6. 3 kilometers an hour is nothing. That's enough for the landing legs to absorb the impact. Yeah, it's not like dropping it on Earth and dropping it on the moon from, like a certain height to get it to 3 kilometers an hour. That's inconsequential.
Our MCC ground team keeps working, confirms whether or not we can receive telemetry from our lander.
So the reason why it's taking a second is because lunar regolith ejecta. Basically, it kicks up a lot of dust, and that does get in the way of the antennas. Moon dust is a pain in the butt, dude. It's like landing in talcum powder.
So they are continuing to investigate.
Yeah, Max, absolutely. They're rated for way higher. That's why I said it looked good, because I didn't see any abrupt stop in the change or abrupt change in the numbers when it got close, which means it touched down really good. So ideally, like what you'd want to do is that thing is a bunch of engines,
still take a little bit of time.
So when you start to get close to the surface, you start shutting down the engines to lower to slowly do a nice light landing on the moon. That's ideally what you want to do with this type of lander. That like the Apollo lander didn't do something like that. It has one descent engine. And it just
all different kinds of expressions
right?
here.
The
it's
LMD
really
was
difficult to tell from our seats.
That sounds right.
And it is so difficult feeling
the numbers
all
look
this now,
right,
but
guys. It
all
looked
we
right.
can do is cheer them up.
But see, what happens is some of that lunar ejecta can break the antenna. I mean, I don't think I needed to tell you that rockets taking off and landing near the surface could be bad for them after last Wednesday. I don't think that needs to be said, but just in case you were wondering, yeah, it's a rocket engine. It can break things. You got to be careful. I will say that this is taking a second.
Please give us a few more moments.
Yeah, I know, Max. Funny story, right?
We are still in the process of confirmation.
Nah, nothing important, Snick. Just a test flight. It is taking a little bit longer, High Vise. I'm starting to think something happened that they didn't anticipate. Uh-oh. We'll see. Also, that monitor is dope. Dude, sometimes this happens, guys. There's really no good way to simulate a landing. Like, how do you do that? Sometimes you just, you have to do the math as much as you possibly can, but you're never going to know until you actually go and do it. If I had to guess...
The team keeps on working tirelessly.
And keep in mind, this is speculation. Bear with me. If I had to guess, from what I saw from those numbers, it looks like the antenna broke.
Attempting to reestablish communication with our lander after the planned landing time has passed.
Could they have redundancy on the antenna? It's possible, Doom, yeah, but remember, you gotta be, with the type of ballistic lunar transfer that this thing went on, sometimes single redundancy is what you need to do because of mass constrictions. It's always a trade-off with engineering, every single freaking time. Now, I don't see any, crap, the mission's lost. I see, these faces seem to suggest that something happened that they weren't sure about. So something, an unknown unknown, basically.
Thank you, everyone, for your patience. I know everyone wants to know the status of our lander. And I assure you, our crew is working on it as we speak.
Okay, Forge. They said that those numbers were telemetry driven, if I'm remembering right, so I'm not 100% sure. Like, anything that I say is just speculation. I'm guessing. I'm guessing based off of what I'm seeing here, but, obviously go to the source. Source information is the best, especially when it comes to engineering, right?
Discovery, go at throttle up.
So, while we continue to confirm, we will be with you again in a few moments Thank you very much for your patience, and we will give you updates as soon as we have them. Thank you for your patience, and we'll be right back.
That doesn't bode well. Ian, I know that NASA has some stake in this game, but I don't know if... Is Hakuto R not using DSN?
Discovery, go at throttle up.
By the way, it was Thursday. Oh, yeah, it was, Nick. You're right. That's not ideal when they roll the stock footage. Now, keep in mind, guys, like, okay. With spacecraft dudes, sometimes, it's not, you know, total mission failure, right? You ever land on KSP and break a landing leg, or you break a piece of science equipment, but you still get some science from the mission? It's not always like a complete failure, you know? And also, I'd like to add that landing anything on the moon in real life is very, very difficult. It ain't Kerbal, all right? There's so much other stuff to take into account than just, oh, you know, I'm going 500 meters a second. I need to make sure I'm going 0 meters a second when I get near the surface. Now, don't get me wrong. That absolutely is a thing. But, you know, for instance, low lunar orbit speed is about 1,600 meters a second. And in Kerbal, it's like 500. It's like a third of it, you know, because Mun is a lot smaller than the actual moon. So this is not an easy thing to do. People tend to look at the Apollo missions with like rose-tinted glasses. Those missions were extremely difficult. Like extremely difficult. So, you know, I think it's important to, you know, if you go to see this and you see all these people, like there was the Bereshit mission that didn't work. It crashed. India tried to land on the moon. It didn't work. This is hard. It's tough to do, man. Really, really difficult. Now, why? Why is it difficult? It's, well, I mean, guidance is one thing. Like, where's your point of reference for the moon? Now, you know, like this isn't, I'm not suggesting that this is what's wrong with it. It's just, you know, the antennas, right? The antennas could break. If the antenna is a directional antenna on this thing and it moved a little bit during landing, it could still be operable, but it could be pointing in the wrong direction. There's a bunch of things that you got to take into account, and it's not like you can go send something to fix it either. It's not KSP, no rescue missions, you know what I mean? Yeah, exactly, Admiral. This stuff is not easy to do. And I will say that, you know, it's like, oh, we landed on the moon 50 years ago. They can't do it. I'd like to add that iSpace is a privately funded company. This isn't a government doing this. iSpace is their own company. It's private. Like, it would be like SpaceX landing on the moon, right? Why? There was an Ariane Space logo. Now, they could have had contracts for scientific equipment, Astra, on board. And it's no doubt that they used European Space Agency facilities to make this thing. But, yeah, it is all privately owned. Now, just because they're using ESA stuff, right, doesn't necessarily mean that, like, oh, you know, that they're a government program. SpaceX uses 39A. That's another good example. Or Blue Origin's using Complex 36, right? Like, that's not... It doesn't mean that, like, you know, oh, they're not totally doing it by themselves. I mean, you need some help to go and land on the moon, man, at the end of the day, too. It's really difficult. No, Squall, no. I said it would be like it, not exactly. Is the landing failed? We're waiting on confirmation. They are showing a lot of stock footage.
Discovery, go at throttle up.
If I had to... They made it to the moon. Question is if it's in a remotely operative state. If I had to guess from what I could tell, now keep in mind I wasn't keeping exact good track on that. I didn't really lock in and watch those numbers until like the last couple of seconds there. The numbers looked right, but it could have just been an animation. It's possible. Did you call it lost gimbal range and atmosphere? Munchies, I definitely saw something that was probably not what they wanted. Unless they were doing... So, okay. We saw the spacecraft slew on the yaw axis. So that indicates a induced yaw on the vehicle. So we were looking at the camera relative to the ground, right? And the camera started turning.
Discovery, go at throttle.
The lander is definitely it's definitely parallel to the ground, and the camera's looking at the ground, right? If we saw the camera rotating, that means that an induced yaw was done on the vehicle. Now, a yaw during a landing burn is not necessarily a bad thing. Induced yaw could just be you honing in your landing site. That's possible. However, that could be anything. And now I will say, I said it was roll at first. It's not roll, it's yaw, because I screwed up camera orientation, right? Induced yaw on the spacecraft, once again, during a retro burn on the moon is fine if you're trying to land precisely. And they might need to. However, I will say that a yaw, a maneuver that moves on the normal anti-normal axis during landing like this does eat up delta V really, really quick. If that behavior was not what they wanted, i.e. if that was deviant engineering behavior, that means it probably crashed. Yeah, probably crashed. But I don't want to wish any bad juju on iSpace or anything. This is an incredibly difficult thing to do.
Discovery.
It is really, really difficult. Just give him a second. It seemed like the speed dropped too slowly for the distance. I mean, the numbers forlorn looked right during landing, but I only saw it in the really last 5 minutes there. And I thought that was telemetry-driven numbers, but their failure to make contact with this after it landed kind of suggests otherwise. So, who knows? Did it tip over? Lord, I don't think it tipped over. Here, let's go back and look. You know, we'll go back and look. I don't think it tipped over. If it did tip over, you would have seen an acceleration for a moment. So it would have gone to like 0.02 up to like 0.03 and then back to 0 immediately. The reason why is because the IMUs, the inertial measuring units on this lander, that it definitely has them. That's like an IMU on a spacecraft is like saying a car has a steering wheel, right? I don't know if it has IMUs for sure. It could be an accelerometer. It could be a bunch of different things to extrapolate where the vehicle is, right? But I think it's a reasonable thing to think that has that. We would have seen an acceleration because the inertial measuring unit would have basically picked up on the vehicle tilting over.
Discovery, go at throttle up.
So I didn't see any acceleration here. These numbers looked right. They looked okay to me. Hey, Mile. Yeah, see, this says lander telemetry, but it says simulation up there. I'm not 100% sure. I think it landed behind a rock. Yeah, Gagan, you gotta remember, it could be something as simple as that. There could be literally a rock in the way. And the regolith, the ejecta, right? Here, hold on. Let me look at that. Let me look at that again. The ejecta, all the dust that it kicks up could get in the way of the antennas, and it's going to take a little while for the dust to settle. Seriously. It's going to take a second. All that dust, there's no air to slow it down, and there's 1/6 the gravity. It'll just keep going. So the dust cloud that this thing kicked up when it landed could be blocking the antenna. That's entirely possible. Lunar Reconnaissance Orbiter should pass over it eventually, Synerd. Within the month, I would say. All right, let's look. Let's watch these numbers. So it was reading a steady speed here. And then it looks like they shut the engines off. Huh. Interesting. It went up from 2 to 3. Let me take a look.
Discovery, go at throttle up. Discovery, go at throttle up.
Hey, Hypersonic, thanks for the resub. Ooh. Those numbers were simulated at around 7 meters to go. Adama 10, I'm not entirely sure they would simulate an induced acceleration above the surface, but I'm not sure. I don't have their telemetry in front of me, you know? We have Atlas at home, Creeper. Atlas at home. Nice, nice. I have faith. Yep. All right, statement. Let's go live. Oh, Reaper. Oh, here we go. All right, what do we got?
Thank you for your patience. As of now, our MCC crew is still continuing to investigate the lander's status. So we ask you to bear with us a little bit longer, and we will be right back. Thank you for your patience.
We'll do that later, Apocalypses. They switched to simulation mode from 200 meters, so there's no live telemetry. All right, let's see. Where was the last time we picked up live telemetry? Let me take a look. Okay, update. Okay. It ticked. All right, I noticed something. It ticked to simulation from update. Let's take a look at the numbers right before it ticked to simulation. What do we have here? Oh, wait a minute. I'm scrubbing through the frames with the caret key. Okay, so... Alright, here's the thing. When that update ticks through, the lander telemetry, and the animation updates, right? So that's real. That's the real numbers right there. I know, because check this out. It goes from 42, and it bumps to 35, which means it sent out a ping, and that was the last piece of telemetry that we got from it. No, hang on. So I needed to do kph to meters a second here. That's 10 meters a second. 10 meters a second at 100 meters, right? Am I looking at that right? Okay. Could the Lunar Reconnaissance Orbiter take a picture of the landing zone? The Lunar Reconnaissance Orbiter should be able to fly over it eventually, Shouten, but I'm not sure when that's going to happen. 9.7 meters a second. Yeah. At 100 meters off the ground. So, for Americans that are watching, this is, I don't know, like 20 miles an hour? Something like that. 20 miles an hour, 330 feet off the ground. And that was the last update that we got from it. And it looks like the animation extrapolated the landing simulation took last given data and made an animation based off of it. Guys, remember what I said? Remember what I said right when we saw those live pictures about how an induced yaw during the burn can basically, it really saps your delta V, like badly. And any induced yaw, if you did it for too long, you'd absolutely run out of fuel. Now, once again, I'm not saying that that's what happened, but that induced yaw could have been planned as far as I know. But we definitely saw the thing slew a little bit from one of the onboard cameras, the live onboard shot. So it could have missed the landing zone. Maybe no antenna can get the signal. Yeah, Frank, that's something to take into account. Like, dude, it's not as simple as KSP, right? Like, it never is. It's rocket science, man. This stuff's hard. Dude, you could do everything right, and the thing could land a meter from where you think it is, from where you think it was going to land, and the antenna might not be positioned right. So, I don't know, man. The fact that it was simulation driven for like the last 300 feet, I don't know, man. You know, if you don't, like, this thing has a bunch of engines around the outside and then a center engine. If you don't get all those engines to simultaneously fire correctly, and like one doesn't turn on like faster than another, you could get yaw, and the time it takes to correct that could mean you could run out of fuel. It's possible. Like, I'm not saying that that's what happened, but I mean, here's the thing. If they were planning on getting a signal by now and they didn't get a signal by now, something did go wrong. I don't think wait 30 minutes after it supposedly landed to get a signal was part of the mission plan. You know what I mean? However, with that being said, just because it didn't do something exactly like what you wanted doesn't necessarily mean it didn't land. A case in point would be Apollo 11. Really, Apollo 11 was not designed. It didn't land exactly where it was supposed to. Neil took manual control of the vehicle and landed it in a spot that wasn't surrounded by rocks because, yeah, he found a nice flat spot. So if any of you guys ever remember playing like Lunar Lander on Atari, right? You know, if you're coming down towards the moon and you burn, right? If you're coming down at an angle and you burn to neutralize your vertical speed, you're going to slew a little bit. You'll kind of translate sideways. That's what Neil did. He hopped on his first landing. So just because it doesn't land where they expect it to land doesn't mean it didn't land. You know what I mean? This doesn't necessarily mean crash. It may be. I mean, once again, I'm wondering about that induced yaw. Or about the yaw from that camera. I'm wondering about that. I don't know if that was planned or not. I don't have the actual thing's telemetry in front of me because I'm not iSpace. You know what I mean? So, you know, just because you know, they don't have a signal, honestly, their antenna could be pointing in the wrong spot. It's that simple. Yeah, it could be something that stupid. Well, I work for the you work for the ESA and S-Track. I know the next steps. We are supporting iSpace for a while. Oh, that's cool, Frank. Wait, S-Tech? Or S-Track? Is S-Track different from S-Tech? Because I was at S-Tech in February, dude. Why not design a ball-shaped drone so it doesn't have to land perfectly? Well, Raging, what if it rolls over and your antenna that's on one side is pointed towards the ground? Seriously. S-Track is the downlink antenna stuff. S-Track is the tracking network of the ESA. Cool, man. That's awesome. Right on. I mean, Frank, tell him, dude. It could be, dude. It's always something stupid like this. It could be something as simple as the antenna ain't pointed in the right direction. If it tipped over, it's definitely not pointed in the right direction, right? Like it's always something that, like, stupid like that. Live. All right.
At this moment, we have not able to confirm successful landing on the lunar surface. Our engineers at MCC is continue to investigate the current status of the lander. Currently, we have not confirmed the communication from the lander. We already confirmed that we have established the communication until very end of the landing. However, now we lost the communication. So we have to assume that we could not complete the landing on the lunar surface. our engineers will continue to investigate the situation, and then we will update you the further information once we finish the investigation. At this moment, what I can tell is we are very proud of the fact that we have already achieved many things during this mission 1. As I said, we have been secured the communication at the very end of the landing. That means we acquired actual flight data during the landing phase.
Good.
That is great achievement for the future missions, Mission 2 and the Mission 3. To that end, that is important to feedback what we learned from this Mission 1 to Mission 2 and the Mission 3. That's why we built our sustainable business model to continue our effort for the future missions. I'd like to thank you, all of the employees who have been contributed to this mission since the beginning of this company and then to the present. And then also our families who continue to support us. And then our shareholders, actual partners, and our customers, and the suppliers, and everyone who believe in iSpace vision.
You'll get it in 2025.
We will keep going. Never quit Lunar Quest.
That's right.
Let me allow to speak in Japanese to the Japanese audience next. 現在のところ、ミッション1のランダウンですね、月面への着陸が確認できておりません。我々のですね MCC のエンジニアが今ですね、得られた情報をもとにですね、調査を継続しております。MCC の報告によりますと、月面のですね、着陸のところまでですね、通信は確立できていた模様ですが、現在通信が確立できていないという状況のようです。この後ですね、さらにエンジニアが状況を調査をしますので、最新の状況が分かり次第ですね、またアップデートさせていただきたいと思います。今ここで私たちが言えることはですね、すでにミッション1はですね、非常に大きな成果を残したということです。先ほど申し上げたように、月面の着陸のところまでですね、通信が確立できていました。ということはですね、実際の着陸までのフライトデータがですね、確実に得られたということです。これをもとにですね、我々の次の使命はミッション2、ミッション3でですね、しっかりとこのナレッジをフィードバックをして、次の技術の成熟度を上げていくということです。そのために我々は継続的なビジネスのできる環境をですね、整えてきました。今回このミッションを進めていくにあたってですね、弊社の社員、この会社のですね設立から今までですね、多くの社員に多大な貢献をしてくれました。そして家族の皆様、そして我々を信じて、我々のビジョンをですね信じ続けてくれた株主の皆様、ハクトワールのパートナーの方々、そしてお客様、サプライヤーの方々、多くの皆様にですね感謝を申し上げたいと思います。我々は歩み続けます。
Oh, thanks, Kraylan. ありがとうございます。You'll get it next time. Yeah, they lost signal, guys. It happens. It sucks, and it's a gut punch, especially after 4 months. This mission launched in December. It took a while to get out there. Everything seemed to be going pretty dang well there, but you know, like landing on the moon is tough, man. It's hard to do. Apollo made it look easy. Really, it really did. And that still wasn't without its, problems. Even the Soviets with the Luna program, some of their lunar probes didn't make it. Heck, some of the NASA's early surveyor missions crashed into the moon. There's pieces of them all over the place. Now, in terms of finding a, like imaging it, I saw a lot of people ask, honestly, it's really difficult to see something that's the size of a small car on a planet that's about 400,000 kilometers away. The moon's 250,000 miles. It's really hard to do that from Earth. With that being said, NASA does have an orbiter around the moon that is it's designed for lunar reconnaissance. It's called the Lunar Reconnaissance Orbiter. That's the name. It's called LRO for short. LRO should be able to image it, and they should be able to figure out what happened. The Lunar Reconnaissance Orbiter is a low lunar orbit observation satellite. It's basically satellite for, what the LRO was originally made for is doing reconnaissance for lunar landing sites for the Constellation program. And then the Constellation program got canceled, and now they use it for the Artemis program and just monitoring stuff like this. It's a really useful satellite. So LRO will be able to image it. Don't get me wrong. LRO wouldn't be able to image it to read the logo on the side, but it should be a good enough image to figure out what happened. When did LRO get launched? 2009. Yeah, so I forget what orbit the Lunar Reconnaissance Orbiter is off the top of my head, Shotten. I know it'll image it eventually. So, I mean, this stuff does happen. It does happen, and, when there's nobody on board, it is tough to correct. The computer only does what it's told. To be honest, I'm surprised the NRO doesn't have a sat in lunar orbit to monitor the Chinese landers. Okay. Sure. Where is the Lunar Reconnaissance Orbiter's current location? Thank you, GraphShark, by the way. Let's take a look. Can you try to simulate this in KSP2 with the data provided? There's not really enough data, especially at the last bit, because it was all simulated. Really hard to tell. Ah.
Discovery, go at throttle up.
Yeah, 8 bits, it happens, dude, but they'll get it on the next try. It's not a problem. They have another landing attempt in basically about a year and a half. They'll get it, dude. They'll get it. NASA didn't land on the moon on the first try, neither did the Soviet Union. Their first NASA probes, and that's with the entirety of Uncle Sam and the entirety of the Soviet space program. The people that launched the first satellite into space, and the people that also put the first person in space. Even these big government space programs of yesteryear still had trouble landing on the moon. For a private company to come that close, to come basically 300 feet off the surface, and fail in the final steps is pretty damn good for a first try. I mean, in many ways, these companies do stand on the shoulders of giants of the past, but also at the same time, commercially funded does not have the blank check that they had during the space program. It's pretty damn good getting that freaking close. No one's gotten that close before. To my knowledge, no privately funded company has gotten anywhere near that close to the surface of the moon. This thing was about 300 feet off the deck, or about 100 meters from the last known telemetry. So, amateur astronomers confirm loss of signal of Hakuto. Yeah, it may have tipped over. It's possible. It's possible it tipped over and it's fine. I don't know what you'd necessarily do in that situation. You can't, it's not like they have SAS, to speak in Kerbal terms, to turn the thing back up right. If it tips over, you're screwed. That's basically mission failed. We'll get him next time. So, I mean, it's possible that the vibrations from all the motors firing 8 bits could have broken the antenna off. It's always something. If I had to guess, If I had to guess, I'm going to guess that that induced yaw from those pictures had something to do with it. It looks like they didn't get a good simultaneous ignition during the landing burn, and it looks like they ran out of fuel. If I had to guess. But running out of fuel doesn't explain why the antenna doesn't work. But then again, if it ran out of fuel 100 meters off the ground, even on the moon, so EJ, I'll drop 500 subs if any human walks on the moon and we can watch a live feed by 2050. All right, I'll remember that. I remember everything, Breezy. Be careful what you say. Worst part is, until they confirm what happens, they can't fix it until the next run. Did the orbit they took there to get there cause a more fuel-taxing insertion? Well, Pyro, the ballistic lunar transfer actually does the opposite of that. But once again, induced yaw will destroy your delta V. If you're burning your engines, so say the vehicle's going this way, right? And the rocket engine is facing this way. You're going this way, the rocket engine is facing this way. Like for a landing burn, right? If you go off axis, you will eat up delta V very quickly. Very quickly. Now you're changing inclination. Why? Why does that eat up delta V, EJ? What does that mean? So changing inclination, or doing what's called an on-orbit plane change, requires you to do a normal or what's called a normal or anti-normal burn in spaceflight. So you know how like a plane has like pitch, yaw, and roll, right? To fly around, right? Spacecraft have pitch, yaw, and roll as well, but they also have directions and point of burn, right? For different maneuvers in space. Now, an on-orbit plane change or a normal anti-normal burn will change an axis of your orbit called inclination. Inclination is basically the angle at which you cross the equator of the celestial body that you're orbiting around, okay? So if I have something that is in a perfect equatorial orbit around the moon, otherwise like my inclination is 0, that means my spacecraft is literally following the equator around the moon. Now, Hakuto R seemed to have a polar insertion from what I could tell from their data. It looked like it had a polar orbit, okay? Polar orbit means you're 90 degrees inclined. So basically you're running perpendicular when you cross the lunar equator. Now, polar orbit insertion does afford you the most amount of launch sites on the moon, most amount of landing sites on the moon. You could pretty much land anywhere. You just got to pick one. And, the moon is slowly moving underneath it because it's always facing towards Earth. And if the moon goes around like this, you'll eventually go over your landing site. It's just going to take a second, right? It'll take a month, depending, right? Now, keep in mind, actually, it'll take about 2 weeks if you're in any given polar orbit, right, to get lined up with the landing site. Now, here's the thing. And this is why that yaw screwed me up, because, okay, they're in a polar orbit insertion, which means they have multiple options for landing sites, okay? Now, if you're going to have to do a normal burn out like that, okay, that means you're changing your inclination, which means your orbit isn't going exactly over the landing site. Now, that could be just an unfortunate timing, right? But there are people that work trajectory optimizations to make sure that this kind of stuff doesn't happen. Now, once again, I just kind of glazed over it, but I want to go back to it. Why is changing inclination such a big deal? Well, long story short is that a low lunar orbit around the moon is going about 1,600 meters a second, 6,000 kilometers an hour. That's pretty fast. It's really hard to turn when you're going 600 kilometers an hour in that direction. It's really hard to go in that direction. This is why it saps delta V. I can be pretty damn confident that the trajectory engineers for this rocket, who are way smarter than me, probably optimized it to a certain point where you wouldn't have to do something like that. The reason why is because, well, this orbit is really tiny. Hakuto R is a very small lunar lander. It's tiny. It's about the size of a Volkswagen Beetle, maybe a little bit smaller than that. With something like that, fuel or mass is your, well, actually, fuel mass. Yeah, I can say fuel mass. The total mass of the vehicle is very important. To keep to a minimum. It's always a trade-off with engineering. And the type of orbit that Hakuto got put into, that ballistic lunar transfer orbit, basically where they launched it out way past the moon, and when the moon came by on its orbit, it pulled it in, requiring the minimal amount of fuel for Delta V for circularization around the moon. Basically, it used most of the moon's gravity to capture it. It tells me that fuel is at a premium, right? Obviously, when you have a lander that small, fuel is very much at a premium. So that tells me that that type of trajectory optimization that we saw there, you know, slewing on the yaw axis like that, is really not something that should be figured into that's basically not supposed to do that. Long story short, they would have had the trajectory optimized enough to where you wouldn't have to make a turn like that. Which is the reason why I think they cut that feed right after it started to do this. Trajectory engineers are way smarter than this. Way smarter than this. You wouldn't have to do a yaw like that to change your orbit, especially since the thing's been up there for 4 months. You can wait a couple of orbits to get lined up with the right landing site. Yeah, Virtual, we could. Hey, glad to see you back amongst the living after the craziness of last week. Yeah, it was fun. Yeah. So that tells me that the thing was not doing... It was doing something they didn't want. And it was doing... Even if it corrected back, you still used up too much fuel doing that correction because the correction wasn't planned. You only have enough fuel to basically land. Once again, now I know people are going to say, well, why not just give it more fuel? Well, physics... It's always a trade-off, guys. Always. Landers tend to have a very high mass fraction. So what does that mean? What's mass fraction? There's a lot of spacecraft on there for not a lot of fuel. Now compare that to a rocket like a Falcon 9. Falcon 9 is mostly fuel tank and with a rocket engine attached to the back, right? Landers are more lander, less fuel tank. Now, there's a relationship here. The mass fraction figures into the delta V formula. It figures into spacecraft range a lot, right? Basically, the more spacecraft you have on your spacecraft, the less fuel you have on your spacecraft, it won't go as far. The more fuel you have on your rocket and the less rocket that you have on your rocket will make it go further, okay? It's important to understand. And so in that regard, because landers just tend to have a pretty bad mass fraction because they have landing legs and all this other stuff that you need to land on the moon, right? Or land even back on the planet, like a heat shield is just dead mass until you actually go and use it, right? Or the space shuttle's wings are basically useless in space until it goes to re-enter, right? That's another good example. You need things to go and land, and those things are going to screw your mass fraction up badly, but that's the price that you pay to land, right? So the fuel margins on this thing probably aren't very high. So that's why I saw that thing and I immediately said, that's not good, right? So if that was unwarranted behavior, and I kind of call it a gut instinct, I suppose. If that is not warranted behavior, then yeah, it probably ran out of fuel. What about a craft like Starship? Relative to orbit insertion, will that basically be running on empty for landing? Yeah, for the most part, Jack. Yeah, absolutely. It's the tyranny of the rocket equation, dude. And this is the reason why people don't make SSTOs. Like, we don't make something that'll just take off Star Wars style and get up into space. I mean, don't get me wrong. We could do that in the future if we find out better ways to have more energy on your rocket and less rocket on your rocket, right? It's all a balance of physics, dude. Some basic eyeballing looking at the Lunar Reconnaissance Orbiter current location and the Atlas crater tells me it will pass over in the next few hours. Yeah, GravShark, that's probably not a coincidence. They probably did that trajectory optimization on purpose. It looks like the LRO is in the relative area of where it was. It was supposed to land up here. Rip Hakuto, the last velocity on screen before the on-screen telemetry entered simulation mode was 31 kilometers an hour at 80 meters. Yeah. I'm going to go ahead and guess, Alex, is that it ran out of fuel and slammed into the ground. That's my guess. Now, keep in mind, that little slew thing, dude, that might have been right, but also sometimes getting your fuel to oxidizer ratio on all this is tough. Things been baking in the sun for a long time, and you have liquid fuel and liquid oxidized. Don't get me wrong, it's hypergolic, so it doesn't boil off, but even heating the fuels to, even if the temperature of the fuel gets a little bit too hot, you're not going to get it. You're not going to mix the fuel correctly, and you could run out of fuel. Happens all the time. Yeah, Mayo Juicer, we'll talk about that in a second. Either way, yeah, if I had to guess, I'm going to guess they ran out of fuel. And, you know, if the thing runs out of fuel, basically if you dry fire rocket engines, right, they have a bunch of different engines, and if it lost pressure, right, one engine maybe didn't, you know, all the engines are firing full bore, one runs out of fuel, the other runs out of fuel, and the thing flips over, and the antenna's pointing towards the ground, which means you've lost signal, right? This thing did have a lot of engines on board, so... And those little vernier engines are designed for precise insertion and precise landing. But in this particular scenario, that may have worked against them. But who knows? We won't know until we kind of see. The LRO will probably get a picture. NASA will image this, abso-freaking-lutely. But it seems like the Sky Crane is less complicated than it seems. Pyro, don't get confused. Everything is complicated. Everything is complicated. Landing anything. Even landing stuff back on Earth. It's complicated, man. Spaceflight's difficult. DM for a screenshot. You have the location wrong where you thought it was under the LOR. I'll circle the rough area. I mean, it's inconsequential, Grab Shark. But yeah, thank you. I appreciate it. It's inconsequential. LRO will fly over it. It doesn't really matter. I appreciate the DM, though. Willie, we'll talk about that soon. They should have used Energizer batteries. They keep going and going and going and going. Yeah, batteries don't get you very far with rocket engines, except Electron. But this isn't Electron, so. Yeah, Farm, that's true. You gotta swap one of the backgrounds for Super Heavy taking off. Yeah, I haven't been at my computer since basically I logged off from the Starship stream the other last week. So yeah, I will eventually. Concept for the Museum of the United States Navy. Oh, that's cool. I think they should have a ship inside one prod. That would be sweet. The Energizer Bunny got arrested, though. It was charged with battery. See this? You can feel the disgust, can't you? I know it's 2023 and we shouldn't judge people, but also... Did I miss the landing? Yeah, Zgogs, the landing attempt happened about 45 minutes ago. I'm going to go ahead and say that this thing is kill. Hakudo is kill. No. It landed. It didn't. Yeah, it didn't make it, guys. Once again, a red flag was them not receiving telemetry right after landing, because usually when you land, the lander will immediately tell you that it landed, and when it doesn't immediately tell you that it landed, that means it did. That means it didn't land. Usually. You know, to be a little bit more specific, it didn't land in one piece. They had live telemetry till about 100 meters up, going about 10 meters a second. And then we got nothing then. So I don't know what happened in that last 100 meters, but I guarantee you it was not good. Thoughtful gifted a sub to Erudite. Thank you very much. Well, worst case scenario is now that there's now a pile of spare parts on the moon ready for the next mission. I like the way you think, Cubion. Yeah, especially since last Thursday. I love how rapid unplanned disassembly is entering the public lexicon. That's really funny to me, actually. Everyone knows what a rut is now. That's awesome. That's awesome. We don't go to the moon because it's easy. Well, Willie, I think a more poignant thing from that exact speech that you're referencing is that, you know, no task worth doing is easy. If it was, everyone would do it. That's what separates the grown-ups from the kids. People who can do, right? If it was easy, everyone would do it. I think the lander has done seppuku. Oh, boy. Walks to the moon because it is easy. Maverick, if you have a way to walk to the moon, can you like let me know so we can make a lot of money? Like, I'm a pretty good sales guy, right? I'm pretty good. I can sell people on things. That's what I do. Yeah, like dude, we can work together. If you have a way to walk there, please let me know. Like a portal gun or something. Space, want to go to 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 Earth, want to go to Earth. Too big. Stoke space update. Yeah, Erudite, it's been linked already. You don't need to post it again. I got it. Thank you. Aviation humor is just twisted. It's just not right. It's I think aviation humor is inherently very dark, Farm. Because if we're not laughing, we'd be crying, and it's very easy to cry when you're, I don't know, for instance, when your lunar spacecraft hits the surface going 60 miles an hour and breaks into 1,000 pieces. Yeah, it's just inherently dark humor, because that's how we cope. That's how we cope with it. That's how we cope with it. Yep. Yep, that's called trauma. The traumatic experience is the thing hitting the moon, not in one piece. This is coping with said trauma. Yes. Give me a spacesuit and rocket, I go fix it. Okay. Of course I did. Oh, no, it hit it in one piece. Yeah. Well, you don't know that for sure. You don't know that for sure. A sudden and abrupt loss of telemetry PY could mean that it exploded. It's possible. Do you think Falcon Heavy will be built entirely in the HIF of Slick 6, or will they build it like normal and close the building on the TE? I don't know, Talon, but that is definitely news that we need to... That's definitely something that needs to be discussed. There was a lot of space news over the weekend. Not to mention the whole Starship thing. But yeah, guys, I guess the important thing to kind of, if we want to sum this whole Hakuto thing up, is that, yo, this is tough. Sometimes you're going to work day and night, decades of time, and it's literally gone in about 5 seconds. But, you know, here's the thing. Once again, I'm parroting basic principles of learning, right? But this is the thing. You learn by failure. This is a really good lesson. The really good lesson is, you know, you don't want to go and do this again and lose it in the last 5 seconds. You know, that trauma can work for you. You know, I don't want this to happen. I don't want to experience this pain again. Let's make the next one work, please. You know, it works for you sometimes, right? Like, and if you like, the only failure is the one you don't learn from, right? This stuff happens, man. It happens. It sucks, and it's annoying, and it's always something stupid. It's always something small. You know, it's always a Michael Bolton moment. You know, I always do that. I always mess up some mundane detail. This is not a mundane detail, Michael. You know, how'd the landing go? It didn't. Losing is learning. That's right. Yeah, dude, they'll learn. They'll figure it out. So will Bereshit. So will everyone else. It just takes time. NASA's landings, even with the blank check from the space race, the survey missions. Look what happened to the early Surveyor and the early Luna missions. They didn't land. They did this. This is what happens. Like here, Surveyor 1. You want to see what happened to Surveyor 1? Surveyor 1 didn't freaking work. I'm pretty sure it's Surveyor 1. It didn't. Actually, Surveyor 1 I think did land on the first try. I think it was Surveyor 2 that took a dump, if I'm remembering right. Yeah, Surveyor 2. It did. One way or another, it's on the moon. Yep. Okay, I have a theory about Slick 6 integration, actually. I had to look up Surveyor, guys. I knew that some of the Surveyors didn't work. Surveyor 3 definitely did work. They landed an Apollo spacecraft next to it. That's a picture of a probe that was sent to the moon on an Atlas Centaur taken by Al Bean. Al Bean took this picture. Yeah. They landed a lunar lander next to it to prove that they could land next to a target. They could do a targeted landing. Yeah, so they did land next to Surveyor 3, which is actually really cool. Why don't they land it like the Mars rovers? Mikey, I can come up with a bunch of different reasons, but the biggest one, dude, is that the moon isn't Mars. I'm not sure how well versed you are in like the lunar environment versus the Martian environment, so I'll start from square one. The moon has no atmosphere, so like Curiosity and Perseverance, they have a heat shield and parachutes. That won't get you very far on the moon. In fact, that'll get you to the ground really quickly, but you won't be able to stop in time. Now, if you're referring to the sky crane, you could sky crane something on the moon if you want to, but you don't really need to. The reason why they do the sky crane thing on Mars is because for the most part, you're coming in on a trans-Earth injection or trans-Martian injection. Basically, you're hitting the atmosphere really, really fast. So they use the heat shield to step on the brakes, and they basically do a propulsive landing with that sky crane. Now, the thing is, when you're trying to land a rover on the surface of Mars that's the size of a Mini Cooper, right? The newer ones, not the old ones. It's too big to be proportionally sized to an old one. The old ones are little tiny ones. I'm talking about the new ones. How do you land that? How do you propulsively land something that big? Do you make a lander first and then roll it off the side? Well, we've done that in the past, but it really doesn't generally work on a scale that big. Honestly, the sky crane with Perseverance and Curiosity, that is the simplest way to get it on the surface fast enough, right? I know it seems ridiculous, right? But now, if you could do something like that on the moon, but there's really no need to, because, like Hakuto was coming in, you can afford basically a more traditional lander, like rocket engines pointed down with landing legs on the moon, because you don't have to worry about atmosphere and stuff like that, right? You don't have to worry about atmosphere. There's no atmosphere on the moon. And there's just gravity, but there's also perturbing forces that you have to kind of take into account, but that's not too bad. It's not too big of a deal. Long story, yeah, once again, the reason why it doesn't do that is because it doesn't need to. It's a lot simpler to land on the moon. And keep in mind, I say it's simpler to land on the moon, that it's all relative. So if we're talking about like some imaginary like difficulty scale, right? Like landing on the moon relative to landing on Mars, they're close to each other, right? But this is like way at the very top of the difficulty scale. If like drawing a stick figure is down here, right? And landing something on the moon and landing something on Mars, that's like a couple miles that way in terms of difficulty, right? But it's all relative. I'd say it's easier to land on the moon than it is on Mars. Well, one, the moon's closer, but Mars you can use more to your advantage because of atmosphere. Basically, the medium in which you're landing is different. You don't try to land a seaplane on land, right? That's kind of the same idea here. There are a bunch of different things, dude, and I just label them all off. But if we want to kind of condense it down to something really, really small, you don't land a seaplane on land unless it's equipped to, right? Some aren't. Some are. Most are, actually, but you get the idea. I mean, why don't we put some airbags for landing? It's more safe. It's always a trade-off, dude. It's always a trade-off, my guy. That would be a lot of work, dude. That's a lot of stuff to get right. I'd say engines are probably a simpler way. You're already using the engines to get that far. Now, the reason why they use the airbags on Mars is, once again, they use the parachute instead. That's why they use the bags. In that particular scenario, because you have some atmosphere and parachutes to slow you down, negating that final impact is not that big of a deal because you have the parachute to slow you down. But on the moon, you don't have the parachute to slow you down. So you're going to need the rocket engine to slow you down. And if you're going to need the rocket engine to slow you down, why not just use the rocket engine to land? Why go through the airbag route at all? Now, don't get me wrong. I'm not saying that simultaneously, I'm not saying that you couldn't land on the moon with bags either. Of course you could. Sure, why not? But if you have the rocket engine plus airbags, that's a lot of redundant mass that you don't necessarily need because you could just land on the rocket engines. But, you know, I'm sure somebody, like, here's the thing, like, there's not one end-all be-all solution to landing on any particular planet, right? This is why, for instance, we have the space shuttle that lands on a runway, or Dragon capsule that lands out in the water, right? Or Starliner that lands in the middle of the desert, or Soyuz that also lands in the middle of the desert, right? There's no right way to do it. There's the best application for what you're trying to do. And the iSpace team determined that using the engines to land was the right move for them. So, you know, I know it's kind of like, that doesn't, like, Mikey, at face value, dude, that probably doesn't make a lot of sense, right? It's like, well, you know, we're sitting here. It's obviously airbags probably would have been afforded to them because their lander's in pieces on the surface of the moon, right? But see, here's the thing. There's a thing that I think a lot of people make this mistake with when they look at spaceflight or any air mishap. It is extraordinarily easy to see, in retrospect, after something fails, a way to fix it. This is the hard part. This is one of the things, you know, everybody parrots around, oh, space is difficult. This is one of the reasons why. Let's take Apollo 12, for instance. Apollo 12 took off, right, in, what was it, late 1969, right? It was the follow-up to the Apollo 11 mission. Apollo 12 took off, and it got hit by lightning right off of the pad. And it basically fried the Saturn V's and batteries for the antenna. Yeah, it basically fried that. So they had to switch to a secondary, to a redundant power source. Now, don't get me wrong, Apollo 12 did make it all the way to the moon. It landed next to Surveyor 3, like what I was just talking about. But also, it's really easy to say in hindsight that you probably shouldn't have launched when a thunderstorm was overhead, right? Like, that's really easy to say in retrospect, right? It's really easy to say, like, oh, just don't launch when it's cloudy. And yeah, now they don't. There is a launch constraint violation that every rocket has to go through now called surface electric fields rule. The surface electric fields rule basically means if there's a lot of potential energy, electrical energy in the clouds, basically a thunderstorm above you, right? It doesn't necessarily need to be raining in Florida for a thunderstorm to happen. Cloud to cloud lightning storms happen every night in Florida. Anybody that lives in Florida knows, you go outside, the sky looks like a strobe light, right? The rule is basically don't launch it and don't make the rocket a gigantic lightning rod, because having a rocket struck by lightning is... I can't say what would happen if a Falcon 9 got struck by lightning or a space shuttle or whatever, but I can tell you that probably nothing good would happen. You know? Can't say exactly, but probably nothing good. You know what I mean? It's really easy to say, oh, well, they just should have used airbags. It's hard to say that beforehand. And this is what I mean about failing. Now they know. Maybe the next one will have airbags, dude. We don't know. Maybe. It's possible. Possible. You know, maybe they'll put airbags on the next one. But they learn now, because it's, and this is why, you know, like SpaceX with Starship the other day, they just sent it. Because now they know what not to do. You definitely know what not to do when you go to launch that thing again, right? That sometimes that post failure clarity, right, is really, really helpful. Because it's really easy to get wound up in the minutia when you go to launch. It's really easy to focus on one thing and maybe not focus on another thing. And then that other thing is the thing that gets you. Like it running out of fuel. Maybe they didn't get the fuel mixture right. And if that's the case with Hakuto R, you can be damn sure that the next one is going to be right, because human want to avoid traumatic experience of lander hitting moon at 100 miles an hour. We don't want that again. That's a traumatic experience. We don't want to experience that again. That's why we learn so well from failure. Does that make sense, dude? Good questions though, Mikey. I mean, honestly, those are the right questions to ask, man. That's the right question to ask. Thank you. That really helped. That really helped me kind of explain it better. I appreciate it. That's right. They should just land in a reverse railgun that they will have already placed on the surface to catch landers in. Yeah, they should do that. Post-RUD clarity, Neon. It's true, man. It's so true. Is that not like that's a good way to put it? It's such a screwed up way to put it, but it's so true. You learn from your failures. Oh my god. That's terrible. Oh, it's so true though. It makes perfect sense. How much is NASA helping SpaceX with their rockets? SpaceX has access to NASA's logic, like kind of their records, dude. That's with the projects that SpaceX is associated with. So it's like, think of NASA as the library that SpaceX is using to study. That's the important thing to understand. Thank you for your explanation and patience. All good, Mikey. No good. Yeah, no problem, dude. Post-RUD clarity. Jeez. Jeepers creepers, man. It's so true. Oh, God. Life's lessons, man. Life's lessons. Post-RUD clarity. You guys kill me. That's so bad. But it's so true. It makes perfect sense. Oh, Neon, we're using that from now on, dude. We're using that post-RUD clarity. I love it. That's so freaking funny, dude. Oh my goodness. I don't know why that's so funny, dude, but it's pretty funny. There are basically two ways to engineer something in things like this. Either over-engineer the poop out of it and remove excess iterations, or do it bare bones and add as needed. I prefer the first way, Tessa, to be honest with you, but that costs the most money. It's easy to say it when you're not spending your own cash on it, you know what I'm saying? Speaking of failures, what's up with New Shepard at the moment? We haven't heard anything for months now. It should be flying sooner rather than later, Sirius. The FAA concluded their accident investigation. Nozzle burn through because they changed the state on the BE-3. They're probably testing a new parameter. Now, Sirius, I have my reservations about testing new things on operational flights and how, you know, you shouldn't do that. But, yeah, I don't know. Lunar Reconnaissance Orbiter scan pass is happening right now. They'll give us a confirmation. Cool. It seems so clear now. So, I quoted Elon from my high school yearbook. Failure is not an option here. If things are not failing, you're not innovating enough. That's right. Yeah, that's true. It was an older booster, right? Yeah, but it wasn't the older booster that had the problem, Jax. It's that they put the BE-3 in a configuration that they thought would improve performance, and that it improved performance on something. It improved the performance on how well the engine was able to eat itself on the way up. Yeah. Did you see my Slick 6 message? I did, Thomas. Say it again because we're still kind of talking about, you know, failure and how it hurts and it's annoying and it's a traumatic experience, but it's something that you should strive for, man. You learn things. Thomas, we were basically talking about post-RUD clarity. Post-RUD clarity. So bad. Yeah, Aqualex. Post-RUD clarity. That's my new favorite thing. It's true. It's true. It's so true. Like, oh, I hate how much that analogy makes sense. I hate it. But it's so good. It's too good to not do. It's something everyone can understand. Yeah, Grab Shark. It's a really good one. Okay. All right. Anyway, we'll switch off to the Hakuto planning and we'll go to EJ's Space and Rocket Review. You guys are chomping at the bit to talk about Starship, aren't you? Anyway, Hokuto R didn't make it, guys. We don't know the exact reason. They lost signal with it basically about 100 meters off the ground. Could be 1,000 failures, dude. There's 1,000 different things. But hopefully iSpace learns from this, and they will, because they got another